Assalamualaikum and hi, I am AZZHAD AZIB from BMMP 1/2. Will present to you about my thesis entitled Optimization of Injection Molding Parameters for Virgin Polypropylene Plastic Material. So this thesis is under the supervision of Mr. Saleh bin Abu Hassan. Without further ado, let's proceed to the introduction of this thesis. Okay. Injection molding used to create components from plastic material, both thermoplastic and thermoset. And the final product quality are needed in order to achieve certain characteristic based on customers' demand. And the next important thing is the parameters are very important for engineers to improve the productivity of the injection molding process. Now let us serve into the objective of this thesis. So there are four objectives in this thesis, which is to determine the most significant injection molding process parameter based on the tensile strength of virgin polypropylene. Next, to optimize the combination of injection molding process parameter for virgin polypropylene, to rank the injection molding process parameter for virgin polypropylene, and lastly, to predict the optimum value of ultimate tensile strength. Every research comes from a problem statement. So this thesis is very important in order to reduce the manufacturing cost to sustain in the market. Next, tensile strength of a material will always be customer's concern. So next, the scope of this research. The scope of this research consists the material of virgin polypropylene, the process of injection molding machine, the injection molding process parameter, which are cooling time, packing time, injection speed, packing pressure, and mold temperature. Taguchi optimization method has been deployed in this research, the study of the ultimate tensile strength. So now we move to the importance of study. So this thesis is very crucial to improve the process parameter of injection molding for polypropylene plastic material. Next, to give the guideline in plastic industry. This will more or less will reduce the time and cost itself. Next, to gain new knowledge about plastic industry. Now, let's proceed to literature review. So, the main topic in this study is injection molding machine. So, what is injection molding machine? How the machine works? So now, injection molding machine is a manufacturing process for producing parts by injecting molten material into a mold, and then it can be performed with a host of materials, mainly including metals, glasses, elastomer, confections, and most commonly thermoplastic and thermosetting polymers. First, if the material for the part is fed into a heated barrel and then remixed and injected into a mold cavity where it cools and hardens to the configuration of the cavity. However, the quality of the product is based on the process parameter setting. So different process parameter produce different quality of a product. Now, the next important thing in this study is obviously the material itself, which is polypropylene. So polypropylene, also known as polypropane, is a thermoplastic polymer used in a wide variety of application, and it is produced via chain growth polymerization from the monomer propylene. Polypropylene belongs to the group of polyolefins and is partially crystalline and non-polar. Its properties are similar to polyethylene, but it is slightly harder and more heat resistant. And next, polypropylene also is the second most widely produced commodity plastic. So what is commodity plastic? Commodity plastic plastic produced in high volumes for application where exceptional material properties are not needed, such as packaging, food container, and household products. In contrast to engineering plastic, commodity plastics tend to be inexpensive to produce and exhibit relatively weak mechanical properties. Some example of commodity plastics are polyethylene, polypropylene, polystyrene, polyvinyl chloride, and polymethyl methacrylate. Now let's proceed to the next chapter, which is methodology. For the material preparation, we must prepare obviously the material itself, which is virgin polypropylene, um, approximately around 25 kilograms to 50 kilograms. Next, the Taguchi optimization method. So first, determine the level of each parameters, and then construct an orthogonal array table with 8 design experiment. So from this, 5 samples will be taken from each experiment, equal to 40 samples in total, and then set the injection molding machine. In tensile test, the value of the ultimate tensile strength of each specimen will be determined using the ASTM D638 dog bone specimen. After all the data has been gathered, the data will be analyzed in Minitab software. As a conclusion for the methodology, we can achieve all the objective, which is which process parameter is the most significant, and then we can determine the rank of each process parameter, the optimum combination of process parameter of injection molding PP, and last but not least, we can predict the optimum result of ultimate tensile strength. Now, proceed to the results and discussion, chapter 4. So, for the result and discussion, design of experiment is very crucial to examine the relationship between various factor and response in a systematic and efficient manner. So basically, in this study, there are two different level of each process parameter, which then few trials were made to determine the mean of ultimate tensile strength. At the end of each run, data of ultimate tensile strength are collected. Then DOE in Minitab was used to identify the quality affecting process circumstances and product component, and then establish the factor setting that optimize the result. Okay, now proceed to findings and data analysis. So based on the orthogonal array, it demonstrates that the lowest value of mean for ultimate tensile strength is 29.2 megapascal, and the maximum value of mean for ultimate tensile strength is 32.2423 megapascal, each from trial 4 and trial 2 respectively. In this study, the ratio, the greater the better, is chosen to improve the prepared parameters. The process parameters with the highest mean value consistently produce the best quality with the least amount of variation. As a result, in this study, the process parameter levels with the most value of mean resulted in a greater prediction of ultimate tensile strength. And next, to determine if the relationship between the response and each factor in the analysis is statistically significant, the p-value for each factor were compared to the significant level using null hypothesis. The null hypothesis state that the term of coefficient is zero, showing that there is no relationship between the factors and the response. Typically, a significant level of 0.05 works well, and if it represents a 5% chance of determining that a relationship exists when there is none. If the p-value is less than or equal to significant level, it is shown that there is a statistically significant relationship between the response variable and the factor. If the p exceeds the significant level, it cannot be concluded that the response variable and factor have a statistically significant relationship. In this study, p-value of packing time stated the smallest value, which is 0.148, while packing time stated the largest value with 0.572. This means that packing time is the most significant factor compared to the other process parameter. The response table is used to select the best level for each factor. The factors that have the greatest influence on each response characteristic using the delta and rank values. Then, the level of this process parameter that correspond with the objective of this study can be evaluated. This is because the optimal level of a process parameter for one ultimate tensor strength may vary slightly from the best level for another ultimate tensor strength. To solve the optimization problem, the result among the combination of factor level is estimated to determine which one reaches the greatest result. In this study, factors with the highest data value is rank 1, which is baking time, followed by injection speed, mold temperature, cooling time, and packing pressure, respectively. Moving on to main effect plot for means. The main effect plots represent the best combination of evaluating process parameter for optimized significant factor. This show the ideal parameters combination for each factor study. In this study, larger the better NS ratio is considered to compare the level of each parameter, which means that the highest value of ultimate tensile strength is selected as the significant factor. According to the main effect plot for means, packing time is indicated as the most significant process parameter by using level 1, which is 10 seconds to get the highest value of ultimate tensile strength with 32.06 megapascal, while packing pressure showed the least significant process with the value of ultimate tensile strength is 31.6 megapascal, also using level 1, which is 40 degrees Celsius. Next, cooling time showed that level 2 tends to give the highest value of ultimate tensile strength with 31.65 megapascal. Injection speed indicated that level 1 process parameter resulted the best ultimate tensile strength with a value of 10 millimeter per second. Mold temperature showed that the level 1 process parameter resulted the highest ultimate tensile strength with a value of 31.68 megapascal. And moving on to predicted result. Based on data analyzed, the optimum process parameter setting in the study are cooling time at level 2, packing time at level 1, injection speed at level 1, mold temperature at level 1, and packing pressure at level 1. It is shown that the predicted value of mean by using the predicted process parameter setting is 33.0642 megapascal, which resulted the highest value of ultimate tensile strength in this study. In this case, the ultimate tensile strength value for the condition setting is at its optimal value. In a conclusion, there are 5 process parameters in injection molding, which are cooling time, packing time, injection speed, mold temperature, and packing pressure that had been studied using orthogonal array from Taguchi method. Then the ultimate tensile strength of polypropylene plastic of dog bone specimen had been examined, and all the objective had been achieved. So all I can say that this study is successful. For future recommendation, there are lots of research can be done in order to improve the quality of the product. In this study, 3 trials have been done during tensile tests. In the future, more trials are required to give the best result. This is very important to reduce the number of errors occur during the testing. Hence, the pattern of the result can be analyzed clearer, as it may increase the reliability on the data of an experiment. The bigger the number of repeated trials, the more certain it may be in a result when declaring either the hypothesis was supported or not. Next, the material property, which is tensile strength, was measured as quality assurance in this study. There are many material properties can be considered in order to produce the best quality out of a product, such as yield strength. So yield strength is the amount of stress that a material can sustain without completely undergo deformation phase or return to its original dimension, while tensile strength only consider the maximum stress
that a material can stand when stretched or pulled before breaking phase. So yield strength is more relevant compared to tensile strength. Um, okay, I guess that's all from me. I hope all the input discussed has been discussed clearer, and without further ado, thank you very much.